Up till now, you may have been wondering where I'm getting these numbers from that I write down. I would get them from the confidence interval or from our normal CDF that we did way back a couple of units ago. Now I'll show you how we're going to get the numbers dealing with hypothesis testing. So we're going to look at the same situation again. I want to show that Jefferson College IQs on average are greater than 100. So mu is the thing that we're looking at. So that is the average IQ for Jeffco. Right? You need to identify what you're talking about. What are we comparing it to? Well, we're saying they're smarter than average, so we're going to compare that to 100. And what are we saying about it? What is our alternate hypothesis type? We're saying that our IQ is greater than 100. Right? That's the thing that we're trying to show. I forgot sample size on here, so I'm sorry. All right, and down there. How big was the sample that we took? Let's go with 25. What was the average of our sample? The average of our sample was 103. Okay, so mu is the actual average for the population. X bar is what we use for the average for the sample. The number we're comparing that to is mu naught, our 100, and our sigma, again, for the population of IQs, that's going to be 15. You need to identify all of that information before we can put it in the calculator. And when we do put it in the calculator, here's where we're going to go. We're going to go to stat, over to test. And now we are looking not at this is the same place we went to get Z interval down there, but we're now looking at Z test. So enter to select Z test, and we're going to do stats. We're never going to choose data, so make sure you get stats highlighted. And we've got to put in our information. Mu naught, that's the number we're comparing to, 100. Our standard deviation is 15. Our X bar is 103. Our sample size is 25. And here we need, this one's multiple choice, we need to choose the one we're trying to show, which is that the average is greater than 100. So we need to choose the one that says greater than. Now, it's important that you choose the right one there, because this would be terrible evidence that our average was less than 100. So if you chose less than 100, you're not going to get appropriate results from this at all. And then we go to calculate. And puts all that stuff on our home screen along with the p-value. And the p-value is 0.1586. So if we are at the significance level of 0.05, this is greater than 0.05. And if this, and this is our doubt is more than 5%, this is not good enough evidence of our claim. So we fail to reject the null hypothesis. Remember, the null hypothesis is that Jefferson College is average. This is not sufficient evidence that that's false, so we have to fail to reject the null hypothesis and accept that we are just average. Now let's do that again one more time. Go back to stat, over to test, select Z test. We're going to change, like we did before, we're going to change our sample size to 100. And these numbers are sticky, so they'll all stay the same until you change them. So now we put in 100 for n, and hopefully you remember what happened when we did that. Our p now, our p-value is down to 0.023, or about 2.3% doubt. That's less than our significance level. So now we can say we reject the null hypothesis in favor of the alternate. We reject the idea that Jefferson College is average in favor of the idea that Jefferson College is above average. Okay, that's the whole thing put together. Let's try another one. My friend claims the average number of pine cones on a tree is 437. So he's claiming mu naught is 437. I'm not sure he's right. So I'm saying I don't know if the average is actually equal to 437. I'm not going to commit to above or below. I want to test his claim. So I count all the pine cones on 12 different trees. So I choose 12 trees, and I find that the average for that sample is only 400. And the standard deviation for my sample is 30. All right, so let's put all this stuff in the calculator here. Let's go to Stat, over to Test, Z-test. Now, we're going to talk about T next time. This is too small a sample to use Z-test, but we'll go with it anyway. Mu naught, the number we're looking at is 437. Standard deviation is 30. The average of my sample actually is 400. The size of my sample, very small, only 12. And the nature of my test is the not equal to, the two-tailed test, because I don't know if I'm talking about being on the upper end or the lower end. I just know that we're not in the middle there. And we calculate. And even though our standard deviation was fairly big and our sample was very small, we were really, really far away from the average number there. So this is very convincing. I think we've run into this in class. 1.93 blah, 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 e minus 5. That's scientific notation. That's 1.93 times 10 to the negative fifth power. So this is 0.0000195. That's 93, whatever. Cover that up. That's very, very small. That's our p-value. That's how much doubt we have. So I absolutely am going to reject the null hypothesis. I'm going to say that claim is wrong, and it just so happens that the reality is lower than that. All right. That's all for this one.